In this video, I'm going to review how to solve consecutive integer problems. All right, in the first example, I'm going to just look at consecutive integers. In the second example, I will talk about consecutive odds and evens, how to set those up. All right, Amy was thinking of 3 consecutive integers that have a sum of 189. So I'm going to set up expressions for these 3 integers. I'm going to make the first one an x. Now the second one, since they're consecutive, that would mean it's 1 bigger. So I say x plus 1 bigger than the first integer. The third one then is going to be not 1 bigger, it's going to be 2 bigger than that first one. Or if you look at it, I just made it 1 bigger than the middle, so that works out. Now, the sum of those means every one of these needs to be added together. So when I add those x's together, I've got 3 x's. Now, whenever I add those constants of 1 and 2 together, I have a total of 3. So I've done the sum of my 3 expressions, and I know that they equal 189. So I say they equal 189. Now I have an equation to solve where I'm going to look at, I want x's on my left and constants on my right. So on the left, the constant of 3 needs to be zeroed out. So I do that with its opposite. And I've got left over on the left 3 x's, on the right 189, take away 3 is 186, and now I just need to divide by 3, and I get x is equal to 62. That means my first one is 62. The second one then, they're consecutive, would be 1 bigger, 63, and that third one would be 1 bigger than that, 64. And if you look at that, 62 plus 63 plus 64 indeed does give you a sum of 189, so it works. All right, now let's look at an example that gives us odd integers. First thing I would like to remind you is that the way that we set up our expressions for odd and even integers is the same. And the reason is odd numbers are all 2 away from each other because they skip the evens, but even numbers are also all 2 away from each other because they skip the odds. The fact that they have the similarity that they're 2 away from each other is why the expressions end up the same. Okay, so it says John was thinking of 3 consecutive odd integers. I'm going to stop and I'm going to write out those expressions. I'm going to make the first integer my x. We always do that. Now the second odd, or the second number, has to be 2 away from that first one because we're going to skip that even. So I say that one is x plus 2. Now my third is going to be either 2 away from the second or 4 away from the first. So that's why we say it's the first, which is my x plus 4, because it's 4 away from the first, but now look, 2 to 4 makes it 2 away from that middle one. So there are my expressions for John's 3 consecutive odd numbers. Now, the fact that it says they have a sum means I've got to add these together. When I add my x's together, I end up with 3 x's, and then my 2 plus 4 gives me 6. So the sum of these 3 consecutive odd integers will be 3 plus 6, and we know that is now equal to, they tell us, 39. So there's an equation that I can solve to figure out what the first number is, and then I'll use logic to come up with the next 2. All right, so 3x plus 6, I would want to cancel out that positive 6 with a negative 6. That gives me 3 x's is equal to 33. Now I would divide by 3, and I see that my first one, my x, is 11. So if the first one is 11, and that worked out because it's odd, the next one would be 2 away, or the next odd number, which is 13. And then my final one would be 2 more away, or the x odd number, which is 15. If you add those together, they will give you a sum of 19. And one of the things I want to address is kids struggle with why the third one is x plus 4. look at my third one compared to the first one. It is 4 bigger. And then it's 2 bigger for that middle, from that middle one. So that's why it makes sense to go x plus 2, and x plus 4.